Now we'll do a quick intro into the ether functional group. Ethers can either be symmetric or asymmetric, depending on if these R groups are the same or if the two R groups are different. As far as nomenclature goes, I'm not going to hold you accountable for this. If you want to read more about it, say for test preparation for some kind of standardized test that you may need to take, you can read about this in the textbook, but I will not be testing you on it in this class. The intermolecular forces between two ether molecules are of course going to be dispersion and then dipole-dipole. While ethers have an H bond acceptor with the oxygen lone pair, they do not have a donor, so ethers are not going to be able to hydrogen bond with each other. So you can see how this compares to the alcohol. Remember that the alcohol, which was able to hydrogen bond with itself, had very high boiling points, but if you compare an ether to a similarly sized alkane, say pentane to diethyl ether, the boiling points are really not that different. And so not being able to hydrogen bond is going to have pretty dramatic consequences on the melting and boiling points of these ethers. However, since ethers do have this H bond acceptor, like alcohols, they're going to be able to at least participate in hydrogen bonding with water. It's not going to be able to do as much hydrogen bonding as an alcohol because it doesn't have the donor and acceptor, but it does have the acceptor. And so you can see compared to pentane, which has really no polarity, just dispersion forces, pentane's very, very insoluble in water. But really ether is comparable to something like butanol in terms of water solubility because it can participate in hydrogen bonding with the solvent. So we just went over this reaction when we introduced alcohols. If you take an alkoxide and react it with an alkyl halide, it will undergo SN2 substitution to give the ether product. And once again, this is called the Williamson ether synthesis. Ethers do have two electrophilic carbons and they have a nucleophilic oxygen, but in reality, ethers are not very reactive. And we will discuss this as we go through the chapter and talk about why this is later. But since they're not very reactive, they're used very often as solvents because they won't interfere with whatever reaction you're running.